The Cartesian coordinate system is a method of defining a point or location in three-dimensional space. A point in space can be located in Cartesian coordinates by measuring along three straight lines from a starting position called the origin. These three lines extend from the origin at right angles, or 90 degrees, to each other. The three lines, also known as axes, are called x, y, and z. Depending upon the direction of the lines from the point of origin, a plus or minus sign is added to the letter of the line, or axis. The y-axis is perpendicular to the x-axis, moving in a forward and back direction. In relation to the cube, the y-axis would run the length of the cube. The y-axis also has a positive and negative direction extending from the origin. The x-axis is a horizontal line extending to the right and left of the point of origin. One direction is positive and the opposite negative. In relation to the cube, the x-axis would run the width of the cube. The z-axis is a perpendicular line to both the x and y axes, moving upward from the origin. In relation to the cube, the z-axis would run up the height of the cube. Like the other two axes, z has a positive and a negative direction. The MCL language has the ability to use points in programs that are specifically identified in Cartesian coordinates. The user can program the robot to make a P-move to specific locations in the Cartesian system. The example shows how a typical command would look. The first three numbers define the x, y, and z coordinates, while the last two define the gripper's pitch and roll positioning. Using Cartesian coordinates gives the operator the advantage of programming specific locations where you want the robot to move. Describe how a move command is specified using Cartesian coordinates. The syntax used to program the P-move command using the Cartesian coordinate system is given in this example. This example shows a line from a robot program that uses the P-move command and Cartesian coordinates in English units. Notice that there is a comma immediately following each coordinate. The less than symbol precedes the coordinates, and the greater than symbol immediately follows the last coordinate. Also, notice that a space must be inserted between the command and the less than character. With English units, the movements of the robot along the x, y, and z axes are expressed in inches. The rotation, r, and pitch, p, of the wrist axes are expressed in degrees. This means the position specified by the P-move command is x equals 5 inches, y equals 18 inches, Z equals 17 inches. Pitch equals negative 90 degrees. Roll equals 0 degrees. If metric units are used, the same program command would appear as shown. With metric units, the movements of the robot along the X, Y, and Z axes are expressed in centimeters, whereas the rotation, R, and pitch, P, of the wrist axes are again expressed in degrees. Using the metric system of measurement, this program line will move the robot's X-axis 12.7 centimeters, the Y-axis 45.72 centimeters, and the Z-axis 43.18 centimeters. The wrist pitch will be positioned at negative 90 degrees, and the rotation of the wrist will be positioned at 0 degrees. Describe how robots are applied to a go, no-go inspection. Inspection systems used in industrial quality control are designed to inspect many different kinds of features of a part. The result of an inspection performed on a feature is a piece of data. There are two types of inspection data: attribute and variable. An example of variable data is the actual diameter of the hole. An example of attribute data is whether or not a hole is present in a part. A go, no-go inspection process is a process that checks for a certain attribute and causes the system to accept, go, or reject, no-go, the part based on whether or not that attribute is present. Robots are used in go, no-go inspection processes to load parts into an inspection device. The inspection device is equipped with a sensor that detects whether or not a feature or attribute is present. This sensor is usually a digital sensor that sends an on or off signal to one of the robot's digital inputs to indicate go or no-go. The robot then decides what needs to be done with a part, based on the result of the inspection. Describe the operation of the command, test I. A go, no-go inspection requires the ability to detect the status of an input and to make a decision based on this information. The test I command can be used to detect whether or not a specific condition is met. The test I command is a special form of the if-then command. It tests a digital input and then branches to a point somewhere else in the program if the test is true. The first argument is the number of the input to be examined. The second item is the condition desired, on or off. The next item is a valid label name or number where the program will jump if the condition is true on the specified input. In the first example, the command would cause the program to jump to the label called Go if input 1 is on. In the second example, the program will jump to the label called Label 15 if input 2 is off. Explain how robots and operators communicate with each other and give an application. Robots are often programmed to communicate with operators through visual devices, such as a computer monitor. A monitor can be used to keep the operator informed of production status or an alarm condition. Operators can also communicate with robots. This is often done using a computer keyboard. The computer keyboard allows the operator to modify the robot's operation while the robot is operating by giving the robot new data. When data is entered into a computer through a keyboard, the computer stores the data in its memory. In order to use this data, the robot needs to be able to access the location in its memory where the data is stored. This is accomplished by assigning a name to the memory location. This name is known as a variable name. Describe the function of two types of variables. There are two types of variables that are used in computer programs: numeric variables and string variables. Numeric variables store numbers. This type of variable is used for calculations or for just holding numeric data. Some robot programs use numeric variables that contain only whole numbers, such as 100, 55, or 1. In these cases, numeric variables that contain decimals will be rounded to the lowest whole number. String variables hold any type of character, including alphabetic characters, numeric characters, spaces, and symbols, such as punctuation marks. The information stored in string variables cannot be used in calculations. Explain 5 rules for naming variables. There are 5 rules that must be followed when creating a variable name, whether it is a numeric variable or a string variable. The name must start with a letter. Variable names are case-sensitive, meaning that it matters whether the characters are in uppercase or in lowercase letters. No spaces can be used in a variable name. The name of a program command for a variable cannot be used. String variables must always be followed by a $sign. For example, the name PART is a numeric variable, while PART $sign is a string variable. Here are some examples of valid variable names. Here are some examples of invalid variable names. Describe 2 ways variable names can be used with move commands. Variables can replace the number of a teach point in a robot program. In this example, the program causes the robot to move to a point number identified by the variable a. For the first cycle, a equals 1, so the robot moves to point 1. In line 4, 1 is added to the variable a, making it equal to 2. This means that when the program repeats its cycle, the robot moves to point 2. Variables can also replace Cartesian coordinates. In this program, the robot moves to an x-coordinate of 7.00, which is the value of the numeric variable a. Describe the operation of the operator interface commands print and printline. The MCL language has 2 commands that allow the robot to output information to the computer monitor: print and printline. The print command outputs messages or the contents of a variable from the robot controller to the computer screen. The message that will be output to the screen is enclosed in quotation marks. The content of a variable is displayed by following the message with a comma and the name of the variable. An example of the print command is shown here. If the value of the variable a is 150, this command would cause the screen to display count equals 150. The print line command outputs messages from the robot controller to the computer screen just like the print command, but the print line command also performs a line feed. An example of the print line command is shown here. In this example, the part is displayed on one line, and good is displayed on the next line. Notice that using the print command places the messages from multiple print statements on the same line. However, the use of multiple print line commands places each message on a new line in the output display. The print line command displays a blank line by including only quotation marks without a message in the command, as shown. Explain. Industrial robots are often used to load and unload inspection devices for measurement of features, such as length or diameter. Some robots, however, actually perform the measurement operation. Robots with a built-in measurement capability have the advantage of conserving movement, thereby increasing speed. Their primary disadvantage is that they cannot achieve the degree of accuracy provided by standalone measurement devices. Describe the operation of. Although industry uses external devices to measure parts, some robots have the unique ability to measure the distance between the fingers of its servo gripper. If a part is placed between the gripper's fingers, the robot can measure the part's size. The command used to do this is the measure command. The measure command gauges the distance between the fingers of the servo gripper. This feature can be used to measure the width of parts. The measure statement is followed by two parentheses that are placed next to each other. To use this command in a program, it is equated to a variable name as shown here. This causes the variable, part width, to store the result of the measurement. For instance, if the distance between the fingers of the gripper were 2 inches, a value of 2 will be stored in the variable part width. The distance is measured in inches or in centimeters. The servo gripper is calibrated to 0 when the gripper fingers are closed during homing.